Hello, my name is Ronan Bamtesiza, and I'm here to explain um, if binary tree that's been provided is actually a binary search tree. And so for a binary search tree to hold true, one, the left child node must be less than the root node, and then the right child node has to be greater than the root node, still the left child node. So what I'm saying is, for example, if 5 is the root node, on the left has to be 3, and then for example on this side has to be 7, 4, 10, but it has to be greater than that. So what that means, when I'm building this function, I, for example, must use a range. Range is something that can help me because we're using a range, for example, negative infinity to positive infinity. I'm able to say, is the root node value a valid value? Yes, it is a valid value. Okay, so if it's valid, then I'm going to look on the left. Is left valid value? Yes, it's valid according to the range, and then the right also. So inside the function, four codes, for example, four major codes will be written. One, the one that will be the best case scenario. The best case scenario is one that is going to help me to make sure that the code does not call itself to the extent that it makes a stack overflow. So my best case scenario is going to be if the node is now, meaning if on the left, on the right, there is no node, like then don't call anything anymore. And so then the next code that I'll implement in is I'm going to check the value. If the node dot value is less than or equal to the mean, or for example, if the node's value is greater than or equal to the maximum value. So if those are the conditions, then return false because that is not right. It evolves, duplicates, and it's not in the range. So what I'm going to do is I'm going to check on the right. For example, every time I got the right, because my function is going to have a node as a parameter and then the minimum value and then the maximum value. So every time I go on the left, I'm going to say, is the node on the left less than, I mean, greater than the minimum value possible? But is it less than the root node? Yes, then that's fine. How about on the right? Is it greater than um, um, is it greater than the node? Yes, it is greater than the root node. Yes, if it's greater than the root node, is it less than the minimum value possible? Yes, 7 is actually lesser than the minimum value possible. Okay, that's right. So for the function to return true, both the left and the right have to meet the criteria, and then that's when it gets to return true. So that's how I build a binary search tree function, or function that you can check if the tree applied to it is a valid binary search tree. Thank